Okay, hey Algebra 2, want to go over a couple things. This is going to be for the week of 4/20. So this entire week, there's going to be two videos. First one's going to be a little lengthy. This is the first video. After the second video, we'll flip this over and we'll see the homework, okay? So rules of exponents. Here's a couple things I want to go over. Let's say I give you x to the power of 5 times x to the power of 2. Same basis with the x, but the exponents are 5 and 2. Well, simple. If I'm multiplying these two, very simple shortcut. I'm just going to add the exponents 5 plus 2. Give us x to the power of 7. Boom. That should be a review from Algebra 1. All right. Well, what if we have this? What if we have x to the power of 5 over x to the power of 2? Well, that's simple. Basically, what we're doing there, that's going to be top minus bottom, or numerator minus denominator for the exponent. So it's going to be 5 minus 2, which is x to the power of 3. Let me take this example, but do the reciprocal of it. So what if I had x to the power of 2 over x to the power of 5? Because that would not be the same thing. That would be top minus bottom, 2 minus 5 this time, which would give us x to the power of negative 3. Now the problem here is we don't normally leave, simplifying, we don't normally leave the exponent as a negative. Simple trick. If you have an exponent that's negative, flip it, make it positive. So we're going to reciprocal this, flip it, make it a fraction, and make that positive. Simple as that. Okay? So if that was x to the power of negative 5, simple, 1 over x to the power of 5. Okay? And then last, what we really need to know is what if I have x to the power of 2, and then that's to the power of 5? Simple. That's the same as saying 2 times 5, which is going to be x to the power of 10. So we have number 1, 2, this is about the same, and then 3. Those are the most important things you need to know for rules of exponents. Okay? So have that in mind while we go on for this lesson. I'm going to erase. Good. Ready, set, go. All right. All right. What if I give you something like this? Let's go x over x to the power of 1/3. Remember, it's a fraction. I'm going to do top minus bottom. So let's do it. The top exponent here is the invisible 1 minus the bottom, which is 1/3. Well, that's going to give us, let's think about this. We have to do 1 minus 1/3, subtracting fractions. That's a 1 over 1. They're not common denominators, so I can multiply this by 3. That's going to give me 3 over 3 minus 1 over 3, which is going to be 2 over 3. And that's good. That's your answer, all nice and dandy. But I do want to show you one more thing. I want to convert this. I want to write this instead of as a fractional exponent. I want to convert this to a root. Okay. So here's a little shortcut that you can do. Top, the numerator, think of that as the power of x, and the bottom, the denominator, think of that as the root. What do I mean by that? Well, let's write this out. This is going to be converted into x to the power of what? 2. But the root has to be a cube root or a third root. Boom, done. Okay, so for example, if I had x to the power of 5 over 2, that would be the same as to the power of 5 and to the square root. But we don't, obviously for square root, we don't put that 2 there. It's 2. Okay. That makes sense? So you can see something like that. Let's move it on now. That in. Okay. Let's do one like this. 64 to the power of 2/3. Think about that for a second. That means 64 to the power of 2 and to the cube root, or to the third root. Now I have two ways to do this. I can do 64 squared right now. But that's not fun. That's a tough number to do, 64 squared. 64 times 64, especially if you don't have a calculator handy. And then I got to cube root that. Oh, it's quite a bit. Or I have a second option. I can cube root this first and then square it. Let's try that first. So I'm going to try cube rooting this first. The cube root of 64, what multiplies with itself 3 times to get us 64? Well, that's easy. It's 4. 4 times 4 is 16. 16 times 4 is 64. So that's a 4. and I'm going to square it. 4 times 4, the final answer. So this entire thing, 64 to the power of 2/3 equals 60. Beautiful. All right. What else are you going to see? You're going to see something like this. Let me do this actually, so I can introduce the next question. So let me intro it first by doing something like this. All right, so keep that in mind. Let's try something like this. 25 to the power of half. Okay? That's going to be 25 to the power of 1 to the square root. I don't put the 2, that's invisible. I also don't need to put the power of 1 because that's also invisible. 25 to the power of 1 is just 25. So I'm asking you for the square root of 25, which is 5. I'm taking the principal square root there. So square root of 25 is 5. Boom, done. Okay, so 25 to the power of 1/2 is 5. What if I did this? Let's spice this up a bit. What if I made that a negative? No difference here. Everything's going to be the same. The only thing that's going to change is what? Let's think about this for a second. The only thing that's going to change is this is going to be reciprocal. So this whole answer is just going to be 1 over 5. Okay? So it's going to be 1 over all this. Because that negative exponent, remember what it does? It flips it. Is what the negative exponent does. Another example, so you can get this down. What if I said 81 to the power of negative 1/2? So I flipped it at the very end. You can decide, hey, I'll flip this from the very beginning. Fraction, make that 81 to the power of positive 1/2. So I'm going to turn that exponent positive, I'm just going to flip it. And now that's going to be 1 over, that's going to be 81 to the power of 1, and then a square root. That's just going to be 1 over 9 as our final answer. Okay, so whether you flip it in the beginning or at the end, I mean, you should be doing it in the beginning, but I mean, if you want to do it like that, the way I did it, that's fine too. All right, moving on. What are we running on? 7 minutes? Oh, we have time. We're good. Let's now go through something a little more spicy. Okay, let's do this now. Erase all that. All right, let's try something like this. What if I gave you 6 to the power of 1/3 times 6 to the power of, make sure I got that right, negative 2/3. All of this to the power of negative 2. Okay, so there's quite a bit going on here. I'm going to tell you right now, there's no point of actually trying to do 6 to the power of 1/3, because that would be 6 to the power of 1 to the cube root. There is no cube root, perfect cube of 6. Okay? There is, but it's not a perfect cube. Okay? There's a cube root, but not a perfect cube. So and same with that. So I'm just going to leave that as is. What I am going to do is I'm going to notice both of these 6's are the same base, but the exponents, now remember what I can do. If the bases are the same and the exponents, you can just add them. So I'm going to add 1 over 3 minus 2 over 3. But you said add them. Well, you're adding a negative, which is basically subtracting. Okay? So 1 over 3 minus 2 over 3 is going to get us negative 1 over 3. And then that whole thing is going to be raised to the negative 2. Rules of exponents. Again, when I'm raising an exponent to another exponent, multiplying. We're basically multiplying. Multiply negative 1 over 3 times negative 2. Negative 1 over 3 times negative 2. First of all, negative times negative is going to give me positive. That's going to be 2 over 3. Now, that's your answer. You can write it like that. You can leave it like that. If you want to, you can convert this and write it as 6 to the power of 2 to the cube root. Doesn't really matter. This is perfectly fine. I'm not going to bother doing anything with this because I know that doesn't simplify any further, because that's going to be 36, and there is no perfect cube of 36. Or I can try to find the cube root of 6 and square that. Again, there's no perfect cube root of 6, so I could just leave that one as is, like this, or like this. I think either is perfectly fine. But you will ultimately need to know both, because on your exam you might see both. You most likely will see both versions one way or another. Okay, and so that's it for this first video, about 10 minutes. Second video, we're going to be doing more square roots and cube roots, simplifying those. You will see the homework questions after the second video. Thanks, guys.